What if we could travel at the speed of light and not break a sweat? Well, that may be possible thanks to NASA finally revealing its new helical rotor engine, capable of breaking the law of physics. The idea of traveling at nearly the speed of light is something that has fascinated scientists and individuals for many years, and one that has been subject to numerous books, science fiction movies, and TV shows. For a long time, it's been thought impossible to travel at the speed of light as a result of Einstein's theory of relativity, which states that moving objects are limited to a speed of 186,282 miles per second, and all other speeds, including movement at near light speed, are impossible. According to the theory, any object traveling at the speed of light would increase exponentially in mass, making travel too energy intensive. According to this theory, even warp speed as depicted in Star Trek is impossible. So does this newly invented engine break the laws of physics and Einstein's theory of relativity? Join us as we explore the new helical engine and the future of space travel. The universe is an ever-expanding place of wonders and mysteries waiting to be uncovered. However, exploring the universe for centuries has been faced with a huge problem. Much like humans who are limited by gravity, spacecraft has also been limited in speed as a result of Einstein's theory of relativity. As humans, we have always dreamed of reaching the ultimate alien destinations by crossing astronomical distances across the cosmos. However, despite our best efforts, space travel has always been limited to just a fraction of the speed of light. Think about this for a minute. The fastest speed a human-built spacecraft has ever traveled is only 46 miles per second. Despite such an incredible speed, it would take more than 4,000 years to reach our nearest star, the Proxima Centauri. Although we could utilize rockets to go through space, the main drawback is that rockets push spacecraft through space rather than propelling them forward. As a result, rockets require an enormous amount of energy to achieve even the most basic speed needed to reach space. Overall, the current limits of our technology and the laws of physics has always been an unbreakable limit and a major obstacle to achieving interstellar exploration. While quantum propulsion, nuclear propulsion, or lasers may be able to help us achieve interstellar travel one day, these advances may lie far, far into the future. However, physics-defying innovations such as a newly developed NASA Speedlight engine may offer us a way to bridge the gap and reach towards interstellar travel. Despite the apparent complexity within the universe, there remain four essential forces in the universe: gravitation, electromagnetism, weak nuclear force, and strong nuclear force. These four fundamental forces have shaped what we perceive as reality and have been dominant for countless billions of years throughout all corners of the universe imaginable. In fact, from start to finish, the Big Bang was caused by these essential cosmic negotiators. The first of these forces is explained by general relativity. When we think about how gravity works, the best theory that has ever been cooked up to explain it is the general relativity theory. This explains not only why things fall down, but also all other aspects like light bending around objects in its path or comets changing direction when they pass near Earth's atmosphere due to their own pull at different distances. It also explains the more famous consequences like black holes, neutron stars, and even the Big Bang itself. The latter three, electromagnetism, weak nuclear force, and strong nuclear force, are described by the Standard Model, which describes all the known particles and their interactions exquisitely, passing every classical and quantum test we've ever devised. While the potential for space travel through nuclear power is just beginning to unravel, future technologies might bring about a world where we could explore other planets without relying on conventional fuels. But at this point in time, all our known methods of propulsion rely either chemical-based or electromagnetic reactions, which means they will never give us access into infinity like their counterparts would if it were possible. So what does the helical rotor engine have to do with all of this? As mentioned earlier, the engine has the potential to break the law of physics as we know it and challenge Einstein's theory of relativity. If successful, This would mean a whole new level of space travel that is not only faster, but also more energy efficient than current propulsion methods. The reason for this, however, comes as a result of a little understood phenomenon known as the Alcubierre drive, an idea according to which a spacecraft could achieve apparent faster-than-light travel by contracting space ahead of it and expanding space behind it. The effect of this then creates a local distortion of space-time in a wave-like manner, which could lead to the creation of a warp bubble that encloses the spacecraft, consequently leaving the bubble and its contents traveling faster than light, leaving behind everything outside the bubble. This concept is based on solutions of Einstein field equations in general relativity, proposed by theoretical physicist Miguel Alcubierre in 1994. Which proposed that a spacecraft could achieve faster-than-light travel by creating a bubble of space around itself and then traversing it while it expands. This way, the ship would be capable of riding the wave like a surfer, utilizing space-time's own energy. David Burns, a NASA engineer at the Marshall Space Flight Center in Alabama, believes the helical rocket concept could take us to the stars without propellant. However, the idea of propellant spacecraft isn't new and has been in existence for decades. In the late 1970s, Robert Cook, a U.S. inventor, patented an engine that supposedly converted centrifugal force into linear motion. Moving ahead to the early 2000s, British inventor Roger Schweier proposed the EM drive, which he claimed could convert trapped microwaves into thrust. However, neither of this concept has been successfully demonstrated and both widely assumed impossible due to violation of the conservation of momentum, a core physical law of the universe. Burns, however, has worked on his design in private, without any sponsorship from NASA, and he admits his concept is massively inefficient. However, he says there is potential to harvest much of the energy that the accelerator loses in heat and radiation. He also suggests ways that momentum could be conserved, such as in the spin of the accelerated ions that could make this new technology capable of propelling a spacecraft to speeds as high as 15 times the speed of light, far exceeding NASA's current fastest spacecraft, the NASA's Juno probe. The helical engine is based on mass-altering effects that occur at near light speed. The engine not only produces thrust in the conventional way through combustion and expansion of propellant, but also generates an electromagnetic field that can push the craft forward, reminiscent of the popular warp drive concept. According to recent research, the helical engine could provide thrust at a rate of 1 g and accelerate a spacecraft of up to 10% the speed of light within an hour. This is almost 100 times faster than any conventional propulsion system and would allow a spacecraft to reach the nearest stars in our galaxy in weeks, compared to centuries using conventional propulsion methods. According to Burns, the engine would be able to get to 99% the speed of light without experiencing time dilation effects and would reach about 15 times the speed of light near the end of its velocity range before experiencing noticeable relativistic effects. At that speed, a trip to Alpha Centauri would only take 4 years, less than half the time taken by NASA's New Horizons craft, which spent more than 9 years traveling to Pluto. So how would it achieve these awesome speeds? Well, the key to the engine is that it doesn't rely on conventional propellants. The rotors are constructed of a thin sheet of conducting material. They are charged so that they repel each other, creating a force field that can be used to move the craft forward. Negative charges are propelled down the vehicle's center line by ionization, while positive charges move around the circumference and into the center as they pass by. On the circumference of the engine, electrons are whipped around faster than those in the center by centrifugal force, which generates an electromagnetic field. As this field builds, it pushes against the charged rotor and propels it forward. Burns's engine came to fruition after observing some rotating plasma in his lab. Plasma is the fourth state of matter and contains positively charged ions, negatively charged electrons and neutrons, and free electrons. Mixtures of these particles are found in the sun and other sources of heat energy. Burns observed a gravity-like force acting on the rotating plasma that led him to question whether this effect could be used for propulsion on a spacecraft. I thought, well, maybe I could use that for propulsion and asked myself if it would be possible to turn this into a rotating helix, he says. Even though he has worked on his design in private, without any sponsorship from NASA, this has not held him back. He states that he is prepared to be embarrassed if he is wrong, but if he is not, humanity will have discovered something truly revolutionary. While we have seen a wide variety of ways in which space travel can be achieved, with propulsion methods and designs for interstellar travel being studied, do you think the Lightspeed engine will become a reality in our lifetime? Share your thoughts in the comments below. And if you want to see the new SpaceX rocket from Elon Musk, which just broke a world record, then check out this video right here. Stay up to date with all the latest findings in the galaxy at space-news.co. And make sure to subscribe for all the latest videos from Space News.
is genuine, Einstein may have been mistaken. However, it is highly thrilling to a physicist. It means we can learn something new about the universe's true nature. Professor Carlos Frank of Durham University, who was among the scientists who drew on Albert Einstein's and others' work to construct today's cosmological theory, had mixed emotions after hearing the news. He commented saying, "I've spent my entire life working on this idea, and my heart tells me that I don't want it to fail. My brain, on the other hand, tells me that the measurements were true and that we should investigate the potential of new physics." The research analyzed 100 million galaxies using the Victor M. Blanco telescope in Chile. The map depicts the distribution of dark matter throughout the universe. The black patches are immense expanses of emptiness known as voids, where physics may apply differently. Dark matter is concentrated in the brilliant parts. Our reality The researchers were able to map out the dark matter present in the clusters thanks to the detail captured by Hubble. They were also able to calculate the mass of each galaxy, which took into account the amount of dark matter. The amount of dark matter in these maps didn't line up on the smaller scale, the dark matter associated with individual cluster galaxies, when compared to simulated galaxy clusters of similar mass and distance. Future missions, such as the Nancy Grace Roman Space Telescope, which is scheduled to launch in the mid-2020s, will employ gravitational lensing to identify even more distant galaxies. This information can subsequently be utilized to create dark matter models. What do you think of these new stunning discoveries? Comment below. By its Atlantic Ocean. It is situated at a depth of 7,717 feet, and the vents which were found in the middle of July 2008 are the furthest northerly black smokers to date. They are of geological importance since they are found in an area of the Earth's crust that is reasonably stable and has fewer hydrothermal vents because of fewer tectonic forces. The water that is vented through these chimneys is heated to about 570 degrees Fahrenheit. Due to the microorganisms that the vents spew, some chimneys appear white in red, in addition to the majority of them being black. A 25-person international scientific team led by the University of Bergen in Norway found the vents were more than 120 nautical miles north of the previously known northernmost vents, which were found in 2005. On board the research vessel GO-SARS, geologist Rolf Pedersen of the University Center for Geobiology oversaw the expeditions in 2005 and 2008. The research vessel was named after the Norwegian marine biologist George Ossian Sars and launched in May 2003. An underwater vehicle that could be controlled remotely was then used to find the vents. There's still a lot to be uncovered, especially parts such as the Mariana Trench. However, few cars can withstand falling into this pitch-black abyss. That's why NASA researchers are working with the Woods Hole Oceanographic Institution in Massachusetts to study and test the bounds of earthly life. Even the terms that the scientists use to describe their missions to this area are borrowed from space exploration. For example, in recent years, marine biologists have sent a number of landers armed with sensors and cameras to crash land on the Hadal Zone's ocean floor in order to collect data. To survey the more unreachable depths, engineers from NASA's Jet Propulsion Laboratory in Southern California are developing a new autonomous underwater vehicle called Orpheus, named for the legendary Greek hero who traveled to the underworld and back. Orpheus employs highly sensitive cameras to recognize rock formations, shells, and other structures on the ocean floor to build up a three-dimensional map filled with markers, similar to the visual navigation technique used by NASA's Perseverance Mars rover or perhaps seabed marks. This not only enables the robot to navigate and recognize locations it has already been to, but it should also enable it to learn more about the biodiversity present in this hostile environment. Tim Shank on Earth, I don't see how we could do exploration on Europa. The underwater search continues, and as scientists continue to explore even deeper and darker zones of the ocean, more thrilling discoveries will be made. What do you think of these underwater discoveries? Comment below.
Ever
part of its space physics research. With their political disagreements already affecting the space industry, China and the US are engaged in a technological arms race for supremacy in everything from artificial intelligence to semiconductors. One instance is the dispute that arose between the two countries last year over the so-called Artemis Accords, a pact that seeks to establish guidelines for ethical and responsible space exploration and is led by NASA. While other nations such as Australia and the UK signed up, China did not. China stated in the 5-year plan that it would cooperate with other countries on issues ranging from global governance to crewed space missions, without mentioning the Artemis Accords. The white paper stated that China would actively participate in creating international regulations addressing outer space under the auspices of the United Nations, and will work collaboratively with other nations to address the issues in ensuring the long-term sustainability of outer space activities. What do you think of China's space plans and ambitions? Could they possibly dominate the industry? Comment below.
James Webb Space Telescope, the proclaimed successor of the Hubble telescope, has been making waves with his How Humans See the Universe. During a press briefing, Christopher Evans, a Webb project scientist of the European Space Agency, said, "Astronomy will never be the same again once we see what Webb can do with these first observations." According to scientists, Webb's groundbreaking technology will delve into every aspect of cosmic history, from our own solar system to the farthest detectable galaxies in the early cosmos and everything in between. How will the telescope achieve this? What technologies make this possible? What can we expect for the future? Keep watching to find out. The James Webb Space Telescope, also known as JWST or Webb, is an orbiting infrared observatory that will complement and extend the Hubble Space Telescope's findings by providing greater wavelength coverage and sensitivity. James Webb, a former NASA administrator who served from February 1961 to October 1968, was honored with the name of the space observation device. Webb worked for NASA, and many people believe that he did more for science than any other government figure, and that the next generation space telescope is only suitably named after him. The first science photographs from the world's most advanced space observatory are not expected until this summer. However, recent test photographs taken during the telescope's final commissioning phase offer a hint of what's to come. During the news briefing Monday, Michael McElwain, Webb's observatory project scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland, said, "These are the finest infrared images ever recorded by a space telescope. The sharpness and amount of pixels in the camera determine the beauty and quality of an astronomical photograph. Webb is quite similar to, and in many respects better than, Hubble in both of these areas. Although Webb's photographs will be infrared, they can be converted into visible ones by a computer, just like NASA has done with Spitzer, which can produce beautiful pictures as well. Webb can also perceive orange and red visible light. Its photos will be unique, yet equally stunning as Hubble's. It's been quite a long journey to this moment, and many were excited as NASA's plans to launch the craft on Christmas after repeated delays last year finally came to fruition. The launch of the telescope has been postponed for about a decade, and its costs had escalated by about $9 billion over budget. Many scientists believe Webb is worth the money and the wait, despite concerns from lawmakers and scientists that it is siphoning funds from other study fields. The Hubble Space Telescope, a 31-year-old observatory famous for taking beautiful photographs of our universe's galaxies, inspired Webb's design. A planetary scientist and astrophysicist at MIT, Sarah Seeger, says, "The Webb marks the culmination of decades, if not centuries, of astronomy. We've been waiting a long time for this." Even before the Hubble Space Telescope launched in 1990, scientists began planning a follow-up mission. It's uncertain how much longer this record-breaking spacecraft will be able to scan and picture the universe after more than 3 decades in space. Webb, on the other hand, fills in the gaps left by its predecessor. According to Eric Smith, Webb's program scientist and chief scientist of NASA's Astrophysics Division. So far, he claims, no telescope compares to Webb. The new observatory, which launched from northern French Guiana near the equator, is a collaboration between the U.S., European, and Canadian space agencies. The necessity to identify faint objects in the distant universe influenced the observatory's design, dictating its size, wavelength coverage, and the need to keep it cool to reduce unwanted background light. James Webb Space Telescope's scientific mission includes more than just studying the first stars and galaxies. It is envisioned as a multi-purpose observatory where astronomers from all over the world can apply for time to do research. James Webb Space Telescope should be able to see through the clouds of dust that enshroud extremely young stars, which are opaque to visible light, by observing in the infrared. Webb can gaze considerably closer to the beginning of time and hunt for the unobserved development of the first galaxies, as well as examine dust clouds where stars and planetary systems are developing now, thanks to the larger wavelengths. Humans have yet to see the period in the history of our universe when galaxies began to form. We still have a lot to learn about how galaxies gained supermassive black holes in their centers, and we're not sure whether the black holes formed the galaxies or the galaxies formed the black holes. Astronomers say we can't look within dust clouds with high resolution to see where stars and planets are forming nearby, but Webb will be able to. It's said to be the largest and most intricate of its kind. 4 crucial pieces of equipment, including a camera for photography, are stored inside, each capable of capturing light from hundreds of millions of kilometers distant. Hundreds of release mechanisms must work like nothing that has ever been done before. Many people predict that the kit will eventually be able to see through dense dust storms that hide distant planets. Getting past this could let humans get closer to life, but scientists doubt that aliens will use it. It is largely unknown how many planetary systems could support life, but Webb could determine whether certain Earth-like worlds have enough water to support oceans. Webb's first target will be determined by a procedure similar to that used for the Hubble Space Telescope, which will include NASA, the European Space Agency, the Canadian Space Agency, and members of the scientific community. The first engineering target will be used to align the mirror segments and focus the telescope before the first science target. It'll most likely be a relatively brilliant star or a star field. According to scientists, Webb will show us things that no other telescope has seen before by viewing the universe at infrared wavelengths. We can only see the first stars and galaxies forming after the Big Bang at infrared wavelengths by looking at them with infrared light, which is not visible to the naked eye. The recent test photographs were captured when the huge golden mirror components of the telescope were successfully aligned. The test photographs demonstrate the observatory's 4 instruments' ability to capture clean, well-focused images. A comparison of photos taken of the same object by Webb's mid-infrared instrument and the now retired Spitzer Space Telescope's infrared array camera produced the most stunning result. Spitzer was the first space telescope to collect high-resolution photographs of the universe in near and mid-infrared light, and was previously part of NASA's Great Observatories program. Webb's massive mirror and sensitive detectors can pick up even more detail than Spitzer, allowing for greater discoveries. Webb's image displays remarkable details of interstellar gas between the stars, according to scientists reviewing the 2 photographs of the Large Magellanic Cloud, a small nearby galaxy of the larger Milky Way. According to the news conference, Marcia Reich, principal investigator for Webb's near-infrared camera and Regents Professor of Astronomy at the University of Arizona, said, "You can appreciate that the images from Webb are going to be better because we have 18 segments, each of which is larger than the single segment, so to speak, that formed the Spitzer's telescope mirror." Webb's main objectives are to investigate galaxy, star, and planet formation in the universe. We must look deep into space to look back in time to witness the very earliest stars and galaxies that originated in the early universe, because it takes light time to travel from there to here. The farther out we look, the further we look back in time. Webb is nearing the completion of its preparations so that it can begin making science observations. "This is what I'd call the home stretch," McElwain remarked. "For commissioning, we had about 1,000 actions planned, and there are only about 200 activities left to perform." Webb's instruments are undergoing final checks and calibrations as the telescope's ground staff analyzes their performance to ensure they are ready to capture data properly. Every instrument has 4 or 5 science modes, each of which must meet specified requirements. Moving target tracking is one of Webb's special modes, which is notably useful for astronomers studying objects in our solar system's frigid regions as they orbit the Sun. These first beautiful color photographs will demonstrate that Webb is fully operational, making the start of many years of study, according to Pontoppidan. Webb's precise targets for these photographs haven't been released because the telescope crew doesn't want to give anything away. And as the team gets closer to obtaining photographs, those goals may shift. What are your thoughts on the James Webb Telescope and what it could mean for the future? Comment below.